Hi everyone. In this lecture I will briefly explain how to design for species. In your first assignment you analyzed the urban system. You mapped the city, vegetation and the water system, and also you choose an area to intervene to improve that system. An area that you know or got to know quite well. In assignment 2 you walked your area and described or mapped 5 species and their habitats in your area. The main question in assignment 3 is how can you improve those areas for species and people with the knowledge you gained in the previous lectures, and for that you will also visit your area again and describe or map how species and people can or cannot use that area and how you can improve the area. Urban ecology design is about combining solutions for climate adaptation such as heat stress and water storage with biodiversity, as well as providing a good space for people. A nice example is this project by Pujiang. A 2-kilometer long street, now planted with only one species of tree. Although the street is going up and down, it's going wide and narrow, runs through peat, clay and sand. So having an enormous potential for different habitats. To add more quality for the 5 selected target species, hedges and a mix of tree species are introduced. At the same time, these interventions provide ecosystem services like cooling, storing water and recreation for people. The mix of tree species and shrubs is also a mix of young and old trees, making the linear forest also more resilient to droughts and flooding. At the same time, the moving behavior, nesting, shelter, safety and food needs are collected for the target species. So in the new design, the beds have connected tree canopies. The hedgehog has a bush continuity where possible, and more shallow water edges create habitats for the dragonflies and provide water for other species. This is the start of a whole food web, a small trophic chain in an urban setting, while at the same time providing quality of life for people. Another example is our own faculty square at our campus at TU Delft. At systems level we have a view of our campus. There we see that our campus is elevated in the north and much lower in the south. So basically all excess water is flooding the southern parts when there is heavy rainfall. A vision was made for our campus, storing more water in the north and adding more forest there and marshlands in the south. The area we choose for intervening at systems level is the square in front of the faculty building of architecture and the built environment. Nowadays a lot of heat stress, paving, no water storage, little biodiversity and not a good public space. To change this, a biosphere or wadi with a forest inside it was suggested and designed, a so-called tree wadi, which can store the rainwater plus the water of the roofs of the surrounding buildings. Also, the canopy of different trees provide cooling with each species having a different cooling capacity. The 25 species of trees also provide more biodiversity as they grow in different levels, some deeper with more water than others which are growing in drier conditions, or having more sun and light providing different microclimates. The biodiversity is also improved by introducing a layered vegetation approach, starting at soil level with annuals and perennials and later with shrubs and trees. Next to that, a range of species will have a spread out flowering season, thus providing nectar to insects for longer periods of time. Also fruit and nuts are provided for birds and small mammals. It is important to use native species where possible, although in cities non-native species can also add the qualities mentioned above, and in some cases the growing factors in urban environments can be so extreme that native species will not survive. This has to be tested. The design for your target or selected species linked to their needs for food, shelter, movement and nesting. So providing this for 5 or more well-chosen target species can result already in a well-integrated habitat. Another issue to take care of is lighting. In general, the darker it is, the better for biodiversity. Yet for people, we like some lighting of a place. So find a way to use different lighting techniques, for example, focusing the direction of the light or changing the color to orange or red, which is better in general. Dealing with heat stress, water storage, having more biodiversity, and at the same time create a nice cool place for people to stay and serving as the main entry to our faculty building is an excellent way to plan and design for synergies in this spot with urban ecology design. To achieve a good composition, we used modeling techniques, drawings and digital 3D models. But even with simple, more hands-on drawings or clay models, one can plan for synergies for species and people, improving habitats at the system and the system as a whole. So many thanks for your attention and enjoy the MOOC.